So next concept what we are going to discuss is types of master data. So when you say types of master data, remember its concept is same. Its concept is same. What is that concept? It is the information. Its property and concept both are same. Okay? And its behavior is same. What is the behavior? Overwriting, right? But how do you categorize the different types of master data? Is see, based on, right? It is categorized based on how we represent the data in the database. So how is it categorized? Is based on how we represent this data in the database. It's purely based upon the representation. It's not based on the behavior or something else. Okay, so we'll say like master data can be represented in three ways. So master data can be represented in three ways in BI. So the first one being called attributes. Next one is called text. And the last one is called hierarchy. So we can represent master data in three different ways: attributes, text, and hierarchy. Okay, same way now you can add here one more step under modeling. What was the last step? Was identifying what type of data we are extracting. Right, so let us say it was master transaction you identify. So suppose let us say if I am extracting master data means, so now what do you have to do? Identify what type of master data we need to extract. Is it attributes or text or hierarchy? Clear? No. See, now we'll see one by one what is attributes. Okay, attributes. So what is attributes? See, whenever we represent master data in such a way that if all other info objects are entirely depending on primary key info object. So what is that we are saying? Whenever we represent now master data in such a way that if all other info objects are entirely depending on primary key info object, so then that is called as attribute type of representation. The main concept of master data itself is that, right? The main concept of master data itself is that, right? See? Now, how is that, see? Excuse me. See the attributes. Now, let us say this is your master table. What I am saying now, this is your primary key now. So what we are saying, all other info objects, let us say name, address and city are the other info objects. What we are saying, they are all depending on what? Customer number. Same way. Suppose if you delete C1 from the database, imagine if you delete C1 from the, what happens? It's going to delete entire record or not? So the main concept is what? Master data means detailed level of information of character info object. So which character is that now? So that means you'll say name, address and city are attributes towards what? Are attributes towards customer number. So this type of representation is called as what? Attributes. Clear what is attributes is? Right? What is that now attributes concept is? See? Whenever you represent now master data in such a fashion that all other info objects are entirely depending on the primary key info object. So then that is called as attribute types of. So now we'll say here what is that now? Name, address and city are attributes towards what? Customer number. So maximum cases what type of representation you are going to use is always attributes. What we said, non-key columns, key column and the non-key columns are nothing but your attributes. Okay? Right. Then, so next is attributes is done, text. Okay, text is also kind of attributes only. Okay, text is also kind of attribute only. Now what we said, SAP supports, we discussed earlier, SAP supports multiple languages we have seen. SAP supports multiple languages we have seen. And that I given the introduction to the system where I represented, where I shown SAP I logged on with English language, I logged on with German language. It supports multiple languages. Now, what is the data that you have loaded for customer number now? C1, right? But when you develop the report, now the end user, a top level manager or whoever it is, the end user, he don't want to see in the report it as C1, he want to clearly see it as customer 1. You want to clearly see it as what? Now, can I load the primary key value as customer 1? Usually we load key values as that much big alphabets. So generally the key value will be always a numeric values, that much of. So that time what I will do? I will use this text. And that too, you want to see customer 1, okay fine. That too with respect to language you want. Let us say if you log on with English language, you want to see it as, for C1, what is that you want to see? Customer 1. Suppose same thing, if you log on with German language, let us say for customer it is called Kunnar. So in German what you want to see? If you log on with German language, in the output you want to see it as Kunnar 1. But if you log on with English language, you have to see it as. Now, if you use like this, can I load now customer 1 and Kunnar 1? That means that will become two separate records. But actually what I want description with respect to language also. Then you will use this what? Text. So what is text now? Okay, text represents, or you can say text maintains. Text maintains what? Language and description. So now see now how is text now? So let us say what is that? Customer number, language and description. So here in this table what is primary key now? One is along with this customer number, language is also a part of primary key. So let us say C1 in English language. What is the description now? Customer 1. Now same C1 In German language, what is that now? Now why it is not overwriting? C1 and C1. Here the key value is what now? C1 and EN. If one more record comes with CN and EN, then it will get. That's what, no? So when I'm saying, that's why what I'm saying, when you load same kind of value means all the key values being same, then it will get, what happens? Overwriting, no? So now, see now? Now when you develop a report, suppose when you execute a report, now again it will ask you for log on details. Same way, suppose if I log on with English language, what you can see is customer 1. Suppose same report if you log on with German language, what you can see? Kunnar 1. Understand? No? So that is what. So when you want to maintain text, so now this description is depending on what? Description is depending on customer number as well as what? Language. Understand the logic? It's also kind of attribute, that's why I said. So description is attribute now towards what? Customer and language. So text, you need not worry about that. You need not create any info object called language or description. It's all default. There will be one small checkbox will be there. If you select it, the text table will be automatically maintained. Understand now? Any doubts with text? Another table. Attribute is a separate table, text is a separate table. Okay? So all master data, every master data means 3 separate tables. Attribute separate table, text separate table, hierarchy separate table. Okay? That's why I am saying it can be represented. Represent means what? In the database how you are representing this? As in a table. So it means I am saying it can be represented in 3 ways means it can be represented in 3 separate tables. Okay? Clear? Yeah, any doubts from this part? I'll go for that. Yeah, tell me, Srinivas. Yes, yes. There will be one small checkbox. If you select that, it will be automatically maintained. You have to load the data, you have to load it. Table will be maintained there. Data will be coming from the source again. See, the model will be ready. For that, how you load, what are the data that you load, it will take. Right. So text is clear. Right. Now, next is hierarchy. Hierarchy. So, you know what is hierarchy? See, usually we will try to avoid maintaining hierarchies, but still, if the client insists, then we'll go for representation of hierarchy type of data. So, what is an hierarchy? It's a level by level representation. Let us say CEO, managing directors, vice presidents, project managers, right, team lead, team member. That is one hierarchy. Or let us say your grandfather, your father, you, your children. That is again the same way. Even you want to represent your master data in level ups and level downs. Then we'll go for hierarchy. So now what does that say? Whenever you want to represent master data in level ups and level downs, we use what we use is hierarchy type of representation. So whether you want to represent now master data in level ups and level downs, then we'll go for hierarchy type of representation. Now suppose, now imagine, let us say I have a sales office in India. So info object name is, let us say, country. What is the data that has been loaded is India. And in India, like, my branches are located into two regions. In India, let us say my branches are located into two regions. Okay, one is north and other one is south. Data is north and now let us say each region I have two sales offices, office A and B, office C and D. So now what is the flexibility for end user? So end user in the report, first he can see India, expand it, he can see north and south. Expand north. So what he can see, let us say A and sales office A and sales office B, sales office C and sales office D. Then, so this is what is sales office. Okay. Then let us say each sales office, imagine again I have each sales office I have two sales representatives. Okay, sales representative 1 and sales representative 2. S1 and so this is what now? This is again, let us say sales rep ID. Okay, right. So like that, each place let us have two sales reps. Actually, it is information of what? This is information of your sales representatives. So sales representative S1 is from office A, is from north region and is from, but representation is how now? Hierarchical form, right? So this kind if you want, then you will go for hierarchy. So front end you can see like this, but how it stores in the database now? Let us say S1 for this parent. You know, when you have hierarchy, it will maintain something called parent IDs. So let us say this is 0 level, this is first level, this is second level, this is. So now for S1, parent ID is what? 1, 2, right? That means sales office is its parent. And what is the data? It will maintain something called parent IDs also. Okay, like then for A, parent ID is 1 and data is what? North. And for that parent ID is 0, data is what? Then same thing for S2 also. What is that? Parent ID is 2, A, its parent ID is 1, its parent ID is 0, India. Now what happens if we store like this hierarchy again? There is some redundancy, right? So it start degrading using hierarchy. What happens? Data stores. One disadvantage is what? which degrades your database performance. And one more thing, is it possible to maintain hierarchy type of data in R3? Or we said R3 is normalized. Wherever redundancy is there, it has been split into a separate table. Wherever redundancy is there, it has been split into. Now, can I maintain any hierarchy type of data in R3? Now, if that is the case, can I extract now data of hierarchy from R3 to BI? I am unable to maintain in R3. Can I extract the data into BI now? It's not possible, right? So what has to be done? What are the data that is there in? What are the data that is there in R3 side? What are the data that is there in R3 side? What you have to do? You have to bring it into one file. This file has to be converted into parent entities and all. So that one has to be loaded into BI. So now extraction is also a problem. Directly I cannot extract from R3, right? So what is that now? Extraction of hierarchy type of data from R3 to BI directly is not possible. Okay, that is a problem with hierarchy. The IRCTC site over there. IRCTC. Okay, next. Okay, extraction of hierarchy type of data from R3 to BI directly is not possible. So that are the problems with what? Those are the problems with what? Hierarchy type of representing. So that's why when generally we don't maintain hierarchies, but still if the client insists, then you will go for maintenance of your hierarchy type of master data. Right? Any doubts in this? Is it clear? Right. So types of master data is clear. Then next, one second. Right. So that is what is hierarchy type of representation. Okay. Then so last concept what we are going to see is types of transaction data. Which types of transaction data. So, when you say types of transaction data, will there be any types in transaction? Will there be any types in transaction data? Transaction data is only one, right? What are the business that is happening? What are the business that is happening only? That's nothing but your transaction data, no? So, but here based on, not based on the representation or not based on the, right? Okay? So, it's purely based upon the data itself we are categorizing. So, what is that now? One is called as actual and second one is called as planned. Right? So, one is called as actual and second one is called planned. So, what is actual and what is planned? What is actual and what is planned? Actual means what? Actual transaction data means what are the business that is happening is actual, right? And what you are planning for the, predicting for the future is planned. So now let us say, imagine you are planning, let us say my next year sales may be some 10 millions. So sales is 10 millions. Is it transaction data or not? Sales is 10 millions is transaction data or not? Yes. But when it comes to reality, right? So when it comes to planned, okay? When it comes to actual, what happens? Actual means what? Your sales may be more than 10 millions or less than 10 millions. The figure what is more than or less than, what exactly is the business that is happening day to day, that is called as actual type of transaction data, and what you are predicting for the future, that is called as planned type of transaction data. In order to calculate the planned type of transaction data, what is required? The actual type of transaction data is required. Now you be a consultant, you are dealing with actual or planned. What we are saying, we are extracting data from R3. R3 consists of what type of transaction data, actual or planned? It's all day-to-day business data is getting updated. That means you are dealing with actual data. So what is the actual data that is there in R3 that we are extracting into BI? So this actual data what is available in BI will be becoming a base for planning applications like APO, Advanced Planning Optimizer. So there are some, in planning applications there are something, okay, called, so, right, in planning applications there are something called APO. Then you have integrated planning, like that, okay? Like that. So, what is it now? Clear? Actual and planned. So, BI, you will be dealing with what? Always actual type of transaction data. Understand now? So, need not worry about planned. Planned is not your task. The actual data only you are going to deal with. Understand now? So, any doubts with the concept, okay? Yes. How about people sitting in front of me? People sitting in front of me? How about online Srinivas? Okay. Fine. We'll go further with these concepts. Okay. So entire your BI depends upon, your BI database is built on these concepts only. Okay. Entire your BI depends upon what? These concepts only. Fine. Now with these things, so we are going to start with, what is it now? BI database design. So we are going to the next concept. What is that now? BI, database. How exactly data is stored in the BI system? How exactly data is stored in the BI system? Okay? Right. Now, when it comes to BI, now BI is called as a multi, R3 is what we said? Two-dimensional, right? But BI is what? It's a multi, camera. Okay, BI is called as what? Multi-dimensional model. R3 is two-dimensional, but BI is what? Multi-dimensional model. So, now what is that? See, in the case of BI, data is stored in the form of what? Cubes. Okay, cube is a multi-dimensional model, right? So cube is, as I said, it is a 16-dimensional structure. So what has been done? Whatever the data that is there, whatever the fact table that you have, or fact table means your transaction table, right? So let us say this is your cube. Okay. So whatever the transaction table that you have has been kept inside a cube. You can imagine one table is hanging inside a cube. So what is that now? Let us say one table is hanging inside a cube. So which table is that now? Fact table. So let us say now a fact table is kept inside a cube. So what is the advantage now? The way you analyze the data right now it is in multiple. The way you look at the data, it is in now multiple angles, multiple dimensions. So now, still to better understand what is the use of this cube is, so let us say like this. Imagine it is your cube. So let us say this table has been kept inside one cube. Okay, let us say this is your cube. Inside a cube there is one table which has been kept. Imagine this table has data like this. A date of transaction, customer, material and revenue. Okay, so this is my table. Okay, now suppose I have some data like this: 2011 02 07 C1 M1 revenue is what? 100. Same way, same thing. Some data is like this. Now what is the data that you are looking now? What you are analyzing now? Revenue. Now what is the advantage for me? I can look at this data in, what are the angles? One angle is date wise. Other angle is customer wise. And one more angle is what? One more angle is what? Material wise. So when you look at now date wise, what is the data now? What is the output now? When you look at now date wise, right? So date wise. So now what is the total revenue now? 600. Clear? So same thing, suppose if you are looking at which angle now? Customer angle. So now what happens? What happens now? C1 is same. 2 plus 1 is 10. C2 is also. What is the total revenue? No, total revenue is same. But is the figures are changing or not? So that is what is slicing and dicing is. The way you analyze the data is different. So now still you want to better interpret. Let us say, in your childhood, like you would have played with a toy wherein it looks like a cube. You have to match for colors. So that how what I can do, I can turn. It will have like three faces will be there. One side or this side. So vertically I can turn, horizontally I can turn. So like that. So that means the way you are analyzing the data is multiple angles. Suppose, see, I'll show you here itself. You can understand. You know. This is not the best figure. This one. You know, so this is one way of looking at the data, or this is another way you can look at the data, or any slide. So slicing and dicing. So the way you want to analyze, now it has become in multiple dimensions, multiple angles. So what is the flexibility for the end user? So let us say end user is seeing the output. Where is that PPT? See now. So let us say like this, end user is seeing the output. So left side you will see the object. What he will do? He will just drag and drop that particular object into output. So that data will drill down. See? So he's just dragging this sales region. So that data will come down. See? So like that, the flexibility for the end user is now he can start analyzing the data in whatever the way. So now let us say sales. Sales, one way of analyzing is region wise or dealer wise or product wise or right state wise or whatever it is. So like so you are going to provide multi-dimensional analysis. That is what is the advantage of your InfoCube. Understand now? So same way here, one more way is like, what was that? Material angle, right? So same thing now for material also. What is that material also? Same thing. So now M1 is same. It becomes what? 400. And M2 is, again total revenue is what? But see the figures, it is 400 and 200, it is 100, 200, 300, it is, the figures are changed. So that is what is the advantage of your info cube. So you will get now multi-dimensional analysis. Slicing and dicing. In one word you want to see. That is, slicing and dicing means is like the way you interpret your data. So now if you develop a report in R3, this and all is not possible. Just R3, what will say, the report output is like in the form of a list. List means only like we can represent. I cannot do any navigation. So that is possible with your multi-dimensional analysis. Understand? And the design of this cube is called as schema design. We are designing the cube is called as what? Schema design. Designing the cube is called as schema design. So schema design can be implemented in different ways. Now the first type of schema design is called star schema. I think you are aware of this star schema. Now right now what is the product that we are learning is BI 7.0, right? Right now what we are learning is, so like that, the earlier version to this BI 7.0 was called, the first version released was called BW 1.0. The first version what is released is called as what? BW 1.0. Okay. So like that, after that one series has come, 1.1, 1.1C like this. Some one series has come. Until this one series, what has been released by SAP, so this is all is based on star schema. Even after one series, so next came is like two series. Okay, BW 2.0, 2.1, 2.1D something, some two series is started. So onto this two series, the design was based on star schema. And star schema has some disadvantages. Star schema has some disadvantages. Okay? So, in order to overcome them, you have moved from star schema to, what are the disadvantages with star schema that has to be overcome? So, you have moved from, you call it as external star schema or BW star schema, anything is same. So, after two series, next started is three series, BAW 3.0, then next came 3.1, 3.1C, 3.1D, or 3.5, 3.0A, lot of three series are there, 3.5. So after BAW 3.5, straight away it is BI 7.0. So now even our 7.0 is also based on, this is even based on what? Right now what is the BI database that you are looking is also, it is designed based on extended star schema. So then after this, you have come up across like something called snowflake schema. So the next type of schema design is called snowflake. SNOWFLAKE, snowflake schema. Okay, snowflake schema we are not using this here. So your Informatica, if you know about Informatica, it is built on snowflake schema. So but our BI is built on extended star schema. So then finally the last one that you have is called hybrid schema. So schema designs of 4 types are there. Okay, star, extended star schema, snowflake, and so what is very important for you? First you have to understand what is star schema. Then we will be seeing what are the disadvantages with star schema. Then how it has overcome with extended star schema. Clear? So first you will understand star, its disadvantages, and how it has overcome with the extended star schema. Okay, that's a big concept. So I require 1.5 hours for that. So I think we'll continue it from tomorrow. So tomorrow we'll see what is star, then its disadvantages, and so I thought today I would have finished this, but it didn't happen. So tomorrow this database design you'll finish. So tomorrow is Thursday, right? So Friday you'll have your first practical class. Okay? Alright.